This is the Lansing Area Software Testers June meetup, and so we're very thankful and happy that Raj Subrameyer was able to be here with us today to talk about how to develop and test AI-based systems. Now, I've known Raj for probably about 5 years or so, and very thankful that got cross paths with him at conferences, and very interested in the presentations that he's done. He's also the owner and principal consultant of Chai Latte Consulting. He helps startups, tools, and service companies build awareness to increase organic website traffic and to generate leads. He's an international keynote speaker and inspires people not just through talk, but through an experience. And he also provides tech career coaching to help professionals reach the next phase of their career path. And so I also wanted to highlight that he's writing a new book. So Raj, why don't you tell us a little bit about your upcoming book project?
Sure. Thanks, Jess, for that introduction. So yeah, as Jess was saying, before I get into the talk, a quick thing about my book, and I had some details in the upcoming slides. So the book is about advancing your career. It's pretty much all the strategies which I've learned over the past 15 years, which transformed my life from an entry-level job position into running my own six-figure business. And I talk about how to get your dream job, how to be successful in it, and how to set yourself miles apart from the competition. So these are tried and tested strategies, which I am currently using for my coaching clients who are VPs, CEOs, CTOs, mid to senior level people in the tech industry trying to get into leadership roles. So that's about my book, and it's going to be available for a pre-order on Amazon and worldwide starting August. And right now I have a pre-order list where people can actually buy their book at a cheaper rate before it hits Amazon, because on Amazon it'll be at a much higher rate. But yeah, I'm super excited about the book, and right now it's in the design and editing stage, and it'll be soon released. So that's about my
title.
It's called Skyrocket Your Career, the no bullshit approach to find your dream job, be successful in it, and transform into a rock star. So it's my real life experiences, starting from me trying to apply for 1,293 jobs in 2008 and converted one job, which was an internship. And so it starts from there. And then I talk about different things I learned along the way, which made me who I am today. But yeah, thanks for letting me talk about my book for a little bit. But I know the other people are here for the actual presentation, the AI talk. So I want to get started with that. And since we have a slightly smaller crowd, so yeah, feel free to keep posting your questions in the Zoom chat window, and I'll try to make sure I answer that during the end of the session, because I think I have a lot of good things to cover and interesting things to cover as well. So before I start, and you can use the Zoom chat window for this, how many of you are confused about different terminologies when it comes to AI, deep learning, neural networks, machine learning? You could just raise your hands because I could see people on the screen. Okay, yeah, or you could use a chat window. But the point is, I think some people are still joining. But the point I want to make was, yes, a lot of people are confused using these terminologies, and I'm going to cover that as part of the talk. My second question was, how many of you think that AI-powered robots are going to take over the world and we're going to be slaves to them? I see a lot of laughing. So, so maybe some people think it's a reality, and some people think that's not going to happen. So I have some good news and bad news for you before I start the talk. I have the answer to the first question, which I was saying, where we're going to demystify different terminologies with AI, deep learning neural networks, so that everyone is on the same page as we progress to the talk and talk about how it's impacting software development and testing. The bad news is I don't have the answer to the second question, but I think the next Terminator movie would definitely cover that. So with that being said, let's get into my talk today. And I'm just trying to look at the time. Cool. It's we have 45 minutes, so I think we have plenty. Jess already introduced me, so I'm not going to go into further details. But apart from what he said, I also write for various magazines and tech companies as well. I provide thought leadership for them on various topics like software development, testing, AI, mindfulness, leadership, motivation. And all the details about me can be found on my website, which you see over there. And you can follow me on Twitter as well. Okay. And about the book, I already talked about it. So it's releasing mid-July. And if you have any questions about it, you could just email me. So let's just get it right into the agenda for today. So this is what we're going to talk about. First thing is I'm going to establish some basics of AI so that everyone can start having conversations about AI and neural networks with other people. Second thing is I'm going to talk about what are the current challenges we have, especially in the context of test automation and software testing and development. Then talk about how AI can solve these challenges. And finally, discuss the future of AI-based development and testing, where we are heading towards and what we could expect as practitioners, right? And 1 second, let me just pin my video over here. Okay, cool. Okay. So let's start with the basics of AI. So on a really, really high level, this is the classification. I know people use this synonymously where AI, ML, deep learning, but there's differences. So on a really high level, on a broader spectrum, we have what is called artificial intelligence. So what is AI? So AI is the area of computer science that deals with building machines that can work and think like human beings, right? That is AI. And a subset of AI is machine learning. So machine learning is a field of study that deals with giving computers the ability to learn without being explicitly programmed. That is machine learning, and it's kind of subset of AI. And it kind of evolved from the study of pattern recognition and computational theory. When I say computational theory, it's a study of learning algorithms, okay? And then finally, underneath that, we have deep learning. So deep learning is based out of the neural network of the human body. So in our human body, we have millions and millions of neurons, and each neuron learns from each other. So me raising my hands, me speaking, everything is based on these interactions. And they took this concept and applied it to the area of computer science. And that's how we have deep learning. So these are the subtle differences between the three terminologies. Although people use it loosely, synonymously, I should say, there are differences between the three words and terminologies. Now the next question is, okay, you told me the definitions, but let me know how it works. What are the concepts behind it? So to cover that, I'm going to talk about some classifications. So at a really high level, machine learning can be classified into three types. You have supervised learning, unsupervised learning, and then reinforced learning. Of course, you have other types of machine learning as well, like transfer learning, generative adversarial networks, you have knowledge graphs. But what we hear in the news and what is used in real life applications are basically these three classifications, and that's what I want to quickly talk about. So first is supervised learning. Supervised learning is when you give labeled data sets and train the AI model. So what do I mean by that? So say you have an AI model to detect images of buttons, okay, from a group of images, which you feed into the AI model. So what you're going to do is you're going to feed in an image of a round button and then say, and label it as round. Then image of a square button, label it as square. Then an image which is not a button at all and say not a button. And then you feed it in the AI model and it then starts training. It learns how to detect buttons because you've labeled it, right? So that is supervised learning. So you're basically trying to make predictions on the current behavior based on learnings from past examples. And that's what it's all about. And if you talk about supervised learning, there are two classification models which I use under supervised learning. One is called regression model. Another one is called a classification model. So people use regression model when they want to make predictions on continuous set of values. So just to dumb it down a little bit, let me give you a really raw example. Say you have a restaurant and you want to build an AI model to detect or to predict in a 2-hour time frame what is the tip amount people give, right? If you want to make predictions on the tip amount, then you're going to use a regression model. That's because the tip amount is a continuous set of values. Some people tip 5%, 10%, 15, 20, and right now I do 25% because it's COVID happening. So the point is, you're trying to make predictions on continuous set of values, like the tip amount, right? And that's where you use a regression model. For the same example, if you're going to use a classification model, the scenario would be that in the same restaurant, say you want to predict how much tip amount a male gives when compared to a female, right? They are finite data sets. You're trying to make predictions on either male or female and how much tip amount they give. So if you build an AI model for that, then you're going to probably use a classification model. And again, don't get bogged down with all the details which I'm saying right now. It's just to make you understand there are two basic models which people use under supervised learning. Then you have unsupervised learning. This is where you give just a bunch of data and let the AI model learn. You don't label it like the supervised learning models. And the model used under unsupervised learning is called the clustering model. So to give you an example of how this works is, so cellular companies like AT&T, Verizon, they do what is called targeted segmentation. For example, I live in Chicago, and what AT&T would do is for people under 30, they would give certain kind of advertisements. And then for people above 50, they give a certain type of advertisements. And for doing this targeted segmentation, they use unsupervised learning models. Then finally, we have what is called reinforced learning. So reinforced learning is based on the concept of rewarding good and bad behavior. So a simple example would be like training a dog. So if you tell a dog, say, sit, and if it rolls, then you would say bad dog, and you won't give it a treat. But if you say sit, and if the dog sits, then you reward it with a treat, right? And that's how the dog knows what to do. You're reinforcing the learning. So for me, cheesecake is a good reward behavior, but unfortunately, AI models do not work that way. So how do AI models work? For that, let's take an example of autonomous car training. So say you have an autonomous car, and if you feed it an image of a straight road, and if the car turns left, you would say bad AI model. And the way you're going to do that is you're going to feed in negative numbers. And these AI models are optimized to feed on as many positive numbers as possible. When you feed it a negative number, it knows that it made a mistake. So it optimizes its learning to get more positive numbers. And that's how you train autonomous cars. So the next time, say you give it an image of a right turn, road with the right turn, and if it turns right, you would say good AI model and give it positive numbers. And that's pretty much on a really, really high level on how reinforced learning works, okay? So now you know what the ML classifications are, and you can hold a conversation. These are literally the basics of what people use in current existing systems. Then you have deep neural networks. I don't want to get into too much details and bore you with it, but just on a high level, this is how deep neural networks work. So we have different inputs, and then you have what is called weighted sums. You feed into these inputs, and then you apply what is called an activation function. So basically, AI models are just mathematical functions, right? So just keep that in mind. And with deep neural networks, what you do is you have the inputs, weighted sums, and then you have what is called an activation function. And there are different types of activation functions. You have ReLU, ELU, which is exponential linear unit. You have sigmoid, you have tangent, but the most popular are sigmoid and tangent. And then what happens is the weighted sums and the input go through this activation function, and then that becomes an output, and that node in turn becomes the input for the next set of layers, just like a neural network, right? From an algorithmic standpoint, this would make more sense, but in general, just remember that they're just a bunch of mathematical functions, and you have something called weighted sums, and you have something called activation functions and hidden layers, and that's all you need to know, okay? But to give you a practical example of how deep neural network training works, so I want to take a couple of examples we could relate to, right? So that you better understand how these AI models are trained. So let's just take our voice assistant, Alexa. So if you have a voice assistant like Alexa or Google Home, how would the AI model training work in these voice assistants? So let me walk you through the process so you understand what exactly happens underneath the hood. So the first thing, if you have an Alexa, is you're going to ask it a question. Hey, Alexa, what's the weather today? And when you say this, 4 things happen in your virtual assistants or voice assistants. The first thing is what is called the trigger word detection. So in order to grab Alexa's attention, you need to say, hey, Alexa. So that's a trigger word. And people have different accents. So for example, I have a thick Texas accent, and similarly, other people have different kind of accents, right? So people in Europe have different kind of accents compared to people in Asia. And what they do is they make people from different accents say the trigger word and detect and train Alexa. So that's how it's able to detect. Alexa could detect me saying something when I say, hey, Alexa, okay? So first thing is trigger word detection. And the next thing is speech recognition. So after the trigger word, then you're going to ask the question. In this case, my question is, what is the weather today? And when you say that sentence, we use natural language processing, or NLP, to detect keywords from your question to try to understand what exactly you want to know. In this case, Alexa is going to detect the keyword weather because that's what you want to know, right? And that's the speech recognition stage. That's the second step. Using NLP, they do that. The third step is intent recognition. So what's the intent of your question? In this case, I wanted weather, but there are other keywords also available in Alexa's database. And what's happening is for each keyword we use, there's already code written underneath the hood for that keyword. So in this case, when I say weather, Alexa immediately starts trying to figure out which keyword it associates it with, whether you're asking for time, weather, call, or trying to make a joke or music. But in this case, I want a weather. And when I say weather, the code underneath weather gets executed in the third stage. And the fourth stage is you hear the weather saying it's 72 degrees Fahrenheit in Chicago. So that is how AI model training actually works on a really, really high level, okay? And to make it more fun, this is something you could do at your home as well. There's a open source application called Quick Draw by Google. And the basic goal of this application is you draw different things, and then Quick Draw is going to predict what you're trying to draw. And Google, man, they're smart people because they made this game so much fun. And so millions of people have already done different drawings, and then it's able to predict what we are drawing accurately. And underneath the hood, what they're doing is they're taking this learning and they're applying it to other systems they have in Google using a concept called transfer learning, right? But anyways, without getting into further details and making it complicated, let's just get into the fun part. So I'm going to show you a live example of how to train a neural network, okay? So you should be able to see my screen and Quick Draw. And you should also be able to hear the volume in a second. So I'm going to say, let's draw. It says draw a toe in under 20 seconds. Okay, so let's see what happens.
I see line or ocean. I see river or stitches or giraffe or nail. I see toothpaste or sword or asparagus or crocodile. I see feather or hand or bracelet. I see dragon. I see bow tie or scorpion or mermaid or angel. I see houseplant.
So
Sorry, I couldn't get it.
As you can see, drawing is not my forte, but let's just try it one more time. So water slide. Okay, I think I can get a water slide for sure. So
I see street light or ear or squiggle or nose. I see stairs or knee or octagon. Oh, I know, it's water slide.
Yay, I got that water slide, right? I know, it's so much fun, right? Okay, let's just do one more example, and then I really have to get into the crux of the talk. But the point, let's do rainbow, okay?
Oh, I know, it's rainbow.
See, literally, I just drew a line and it said rainbow, right? Yeah, I can go on and on. It's a super fun exercise. But the point is, if you really want to show people how a neural network works, just open this drawing, this application, and it's going to predict based on your drawing, right? But those are pretty much the basics you need to know about how to train neural networks. And there are also a lot of open source libraries out there where you can build your own neural networks. And mainly, they're pretty much in JavaScript or Python. So these are some open source libraries which are available. I had a couple of sample projects on my Git repo. You could always check it out. Literally, I have a README file. If you just follow the README file within 5 minutes, you can make your own neural network as well, okay? So this Git repo, and you can check it out. But yeah, so that covers pretty much the basics and introduction of what you need to know about AI, ML, and everything which you hear in the news and media, right? And now let's talk about the whole software development and testing aspect of it, which is what are the challenges and how AI is going to help solve those challenges. So let's first start with the challenges. These are the 5 major challenges companies have right now, which is hindering them from releasing products much faster to customers, right? Because with in the current day and age, customer needs are rapidly and exponentially increasing. So we need to have rapid release cycles. But these are 5 factors which always affects release cycles. So let's just quickly talk about these challenges. So first is skill set. So getting skilled testers, first of all, it's really time consuming. Second of all, they're pretty expensive as well, right? Skilled testers are hard to find these days. And not a lot of companies can afford it. Probably TechSmith can afford it, but the point is a lot of startup companies and mid-tier companies cannot afford hiring a lot of skilled testers. So that has been a major challenge for companies to release their products faster because they don't have an actual tester role. And then literally they ask anyone else who's free to do testing, and that has become a big bottleneck. So skill set is the #1 challenge. Then we have the challenge of authoring. So now you hire skilled testers, and then you start writing automation code. But the problem is they don't pay attention to the good practices in authoring your tests, like parameterization, reusability, data-driven testing, keyword-driven testing. All those things is something you need to keep in mind, because if you don't apply these concepts in your automation code, it is going to affect your release cycles because you're going to spend so much time just writing hugely coupled automation code. So that's the second challenge. Then we have the challenge of initialization states. This is something mainly a lot of newbies do not pay attention to. That's why we do mentoring so that they don't make mistakes like this. Say, for example, you have the Amazon shopping cart, and then you write automation code to add items to the cart, right? So first it's 0 items, and then you add another item in the cart when you run the automation code, and you're super happy. What happens when you run the automation code again? The odds are, if you didn't bring back the Amazon cart back to its initial state, what's going to happen is every time you run the automation code, it's going to be 2, 3, 4, 5, 6, 7, and it's going to keep incrementing, right? And this is a really common problem which we see in teams where they don't pay attention to the initialization states, returning the application back to its initial state. So that is something which is affecting release cycles and team productivity as well. Then you have the challenge of maintenance. So say you write 10 scripts, and then everything is passing, you're super happy. And next day you come in and all 10 scripts fail. How many of you have had this situation before? So literally most of us, right? This is the common problem we face when you write automation code, which is maintenance. In fact, a research recently conducted by DZone found that 30% of a tester's time goes into maintenance, which is crazy. Imagine even if you could shave off 5% of the time, how much stuff you can get done in your teams or at your work. So maintenance is a really big problem, and that is kind of the biggest problem which people are using AI for as well, which I'm going to talk about in the upcoming slides. So remember, maintenance is a really, really big problem. And then finally, we also have the challenge of scale. So now say you have 500 tests, and then you're running it every day, and you find that 100 to 150 tests are constantly failing. So you have to spend 4 to 5 hours trying to troubleshoot it, right? So as your test suite grows, that comes with its own set of challenges. And you also have the challenge of hardware resources, because you want to run tests in parallel, you want to run tests faster, you want to find defects faster before they make it to production, right? And a lot of people do not have the sufficient hardware resources, or when they go to cloud-based solutions, they become really expensive. So these are some of the biggest challenges which we are seeing, especially from a test automation standpoint, because that's where people are trying to go with DevOps and continuous testing. So how AI can solve these challenges, right? And that's what we're going to talk about in the upcoming slides. So the two aspects I wanted to cover when we talk about AI and how it applies to systems. First is developing and testing AI-based systems. The second is AI-based development and testing. You see the subtle difference there? So there are two aspects we want to cover. So first, I'm going to start with developing and testing AI-based systems. So if you are a tester or a developer, how are you going to interact with these AI-based systems? And how are you going to make sure it's safe for people using it in production? So let's start with some context. So currently, AI is a black box. No one knows how it makes its decisions. You just give a bunch of data sets, it gets trained, and then make some decisions based on the training. Only recently, a study was conducted in MIT where the researchers were able to make the AI rationalize how it's making its decisions. But again, the study is in a really primitive stage, and it's going to take much more time for it to generalize to a larger audience and become a standard. So for now, AI is a black box. So given this context, how are we developers and testers going to interact with these systems, right? So here are some strategies for you to apply when you interact with these systems. So first thing is you need to make sure you have more inclusive data sets. So what do I mean by that? So about 3-4 years ago, Google Photos came up with a new AI model to categorize pictures automatically for us to make life easier. But unfortunately, what happened was it started categorizing people of African American descent as gorillas, right? The problem there was the person who actually trained the Google Photos app, the AI model used in the app, didn't consider using images of people who weren't white. If he or she had actually used images of people from Asia or Europe or different color people, then the AI model would have trained to recognize those pictures appropriately. But apparently that didn't happen and became a huge issue. So you as testers and developers need to ensure the data sets which are used for training the AI model has a lot of diversity and a lot of mixture in it. It's just similar to how we choose test data right now. You want to make sure you have the right combinations. And similarly, now for training an AI model, you need to ensure the data sets are diverse and has different combinations. So keep that in mind. The second thing is you need to have an auditing process. There needs to be a group of people who ensures that the AI model training is happening as expected. And this audit can happen once a month or once in 3 months or once in 6 months, but there needs to be a group of people or a body in your companies making sure whatever you're doing with the AI model is giving the right decisions and it's actually working as expected. So auditing process is really important when you start interacting with these AI-based systems. Then you have testing which you need to do for adversarial attacks. So just like SQL injection, you have similar kind of attacks for AI models as well. So let's just go back to the Google Photos app, right? What an attacker could do is he or she could modify a couple of pixels in an image and skew the learning of the AI model. So when it's released in production, it's going to cause different outcomes which you haven't trained it for, right? And it's going to behave abnormally. So that is a kind of attack. And then think about this. Again, going back to the image app because it's much easier to understand. We all have festivals in the US, right? Mardi Gras festival, then we have St. Patrick's Day festival. And during the festivals, you're going to see people wearing funky glasses like that or costumes or dresses. If you feed this image to an AI model, is it going to recognize recognize a picture as a female? Or it's not, or would it say that, okay, this is not a human, right? These are the edge cases you need to think about, because when it comes to images especially, you need to train the AI model with different kind of images. And this is something which is really normal and you really need to keep in mind when interacting with these systems. And say you're working in an autonomous car company and you're training an autonomous car, what happens if it sees a stop sign like this? Is it going to stop? Or is it going to just keep moving forward, right? So these are the edge cases you need to think about when you are training your AI models, right? And you have other types of adversarial attacks which can happen. The first one is deep fakes, where people can synthesize videos of other people saying things which they are not actually saying. So recently on Twitter, there was a video of Obama saying something, but apparently it was just a synthesized video using an AI model, right? And it was just him, but another person's voice, and they were able to modify it. So deepfakes is a big problem right now. And if you have an application which has a lot of social media interaction, this is something you need to keep in mind as well. You need a test for this. Then you also have adversarial t-shirts. Say you're working for image recognition company, especially say in security space. What happens when you wear a t-shirt like this? So right now they're coming up with what is called adversarial t-shirts. You can buy from Amazon, and you can use it for testing your AI model to see whether it recognizes the person wearing the t-shirt. In fact, this picture which I took, it was from a study which was conducted where they found that when you wore t-shirts like this, on an average, you could fool an AI model with about 78% accuracy. So it won't detect that there's a human if it detects a image and the t-shirt like this, right? So these are kind of the adversarial attacks I'm talking about, which you need to keep in mind when interacting with these AI-based systems. And then finally, we have the problems of security and privacy. A recent study found that out of 176 countries, 75 of them use AI models for surveying citizens through location tracking and facial recognition. And of course, the US is included in that list along with China and UK as well, right? So if you're working for a company, you need to make sure the data security and other standards do not affect ethical and moral standards of people. So those are some of the things as as practitioners we need to think about. So we talked about developing and testing AI-based systems. Now we're going to talk about the corollary, which is AI-based development and testing. And this you can relate to it more because this is what literally is going to also change the way you're testing your current existing systems. So let's talk about the impact of AI, how people are using AI in software testing first. There's a lot of work going on in different aspects of software testing, but the biggest advancements and work we're seeing is how they're using AI for software test automation, specifically in the UI test automation space. So I wanted to talk to you about what is the future and what are you going to see in terms of test automation in the upcoming months and years. So say, for example, you have this web page, right? I randomly made a screenshot here just for understanding the concept. So this is a simple web page where it's a login page with a username password field, a username password text box, a login button, and yeah, pretty much, you know, a simple login page. And it's made up of multiple attributes. You have IDs, name, class, tag names, type attributes, value attributes, so on and so forth, right? Say you write an automation script to verify the label name, whether username password is there, and then you enter the username password in the username password fields and then click on login button. Say you write an automation code for that and then it passes, you're all happy. Then a developer comes as usual and says, you know what? I don't like the username password label. Let's go change it. I'm going to change it to user instead of the username label, right? You run the same automation code which you ran in my previous example. What do you think is going to happen? So the odds are, if you're using the name attribute to locate that username label and ensure it's correct, the test is going to break. Or say a developer comes and changes the ID attribute of any of these elements which you use in your automation script, the test is going to break. And that is the biggest problem we're having with UI test and automation for the past 30 years, where you're using what is called single location strategy, which is using a single attribute to locate a single element on a page, right? And that's where AI is going to help you. With AI, what you could do is you could use dynamic location strategy. So what this means is when you use AI models for the same example, when you run the script, the test won't fail. The AI model would say, wait a minute, I see the username label changed to user, but I'm not going to fail the test. Let me look at other attributes of the username label to see whether I can uniquely identify that element, right? So what's happening in real time is for each and every element you interact with, the AI model underneath the hood is extracting multiple attributes of these elements. So for this username label example, if the label name change, immediately look at the ID attribute. If the ID change, look at the class attribute. Class change, tag attribute. Tag change, it'll keep going to find different ways to locate that element. And that is called dynamic location strategy. And all the AI test automation tools you're hearing out there right now are using dynamic location strategy. They use their own proprietary algorithms, but the concept is exactly the same, where they're trying to extract multiple attributes for each and every element to make your test more stable and to increase, to reduce the maintenance time you spend, right? So that is going to be, that's the future of test automation. And that's what companies are currently working on. So as a result of using smart location strategy or dynamic location strategy, your maintenance time is going to reduce, and then your tests are going to be much smarter because the more tests you run, the AI models get trained to detect changes in the UI pages, and then it's going to adapt to changes accordingly so that you don't have to keep fixing this every time something changes, right? And again, remember, I'm just talking about only if the attribute change. I'm not talking about if the functionality changes, because if the functionality changes, no matter whether you're using AI or not, it's going to fail. But if just one or two attributes change, the test can still run. And in the end, it could give you a report saying, hey, dude, I'm just letting you know I passed the test, but the label name changed, just to let you know, but the functionality still remains the same. So that's the extent it's going to we are going to get to, because say you're again running 500 tests, it doesn't make sense that like for a username label change, for just if that change happens, it doesn't make sense to fail in the 200th test and not run the rest of the test, right? So you just want all the tests to run and then finally get reports about what happened. But anyways, that is smart location strategy, and that's what people are currently working on. Next is autonomous testing. What you can do with an AI model is you can make it observe what you're doing in production, like how you're using the apps in production. And based on the user flows which you're doing in production, it can automatically start creating tests for you and make suggestions for you and create reusable components. Say, for example, say you're using an insurance application and you log into your insurance application and then you do different quotes or you do some billing, whatever flows. And throughout the day, say you're using the same set of username password again and again. And if you use 3 to 4 user flows multiple times, what the AI model could do is it would say, hey, I saw that you used the same username password combination like 50 times. Can I create a reusable component for you? And it's also going to say that you use these 6 flows multiple amount of times. So could I create a test for you so that you don't have to repeat it again? And then it could automatically create tests for you. So autonomous testing is something people are working on. I'm consulting with 2 companies right now which are working on the exact same thing. And it's just phenomenal what can be accomplished. So that is something which is coming up as well. Then you have UI-based TDD. So we have so many agile processes. We have BDD, ATDD, SDD, which is Stack Overflow Driven Development. And then now you have UI-based test-driven development. So what potentially is going to happen is, remember I was saying you feed in different images and the AI model learns. So they're going to take these mockups of different features which have to be implemented and feed it into the AI model. And the AI model will start recognizes common elements like login buttons, username, password fields. And while the developer is building that feature, in parallel, the AI model can actually start creating tests based on these mockups. And once and by the time the developer actually finishes implementing the feature, the tests are already written by the AI model. And literally you run the test against the developed feature and you see whether it's pass or fail. And that's what is happening right now, UI-based test-driven development. There are a couple of companies which are working on this right now. And the potential seems really good because it's going to save a lot more time for us so that we can do more creative exploratory testing while the AI models can start creating tests for us. So that's something which is coming up as well. And of course, there are more things coming up, but these are the 3 things which are directly going to impact your job right now. So we talked about how AI is impacting software testing. I quickly wanted to talk about how AI is impacting software development. And I know there are 8 minutes left, so don't worry, I am going to finish it on time. So there are a lot of AI-based developer tools out there to make developers' job a lot easier. So let's start with Microsoft Visual Studio IntelliCode. So this is an editor for coding in C and C++. And what they have an AI model underneath the hood. And what it does is it can detect, learn, and suggest coding styles and design patterns while the programmer is actually writing code based on how he or she has already written previous code, right? And it could suggest different reusable components to be created. So it's learning based on your programming styles. So Visual Studio IntelliCode is widely used right now. That is something, if you hear IntelliCode, then you know that it's like AI-based IDE. Similar concept, you have CoData, which is same AI-based IDE for Java and Scala languages. Then you have Kite for Python. Then you have Mendix for mobile app development. Then finally, you have DeepCode. So just like SonarQube for static analysis, you have DeepCode, which uses AI to predict vulnerabilities in your code, even before it's going to happen. So these are some widely used tools currently, which has AI in it as well. Okay, just so that you're aware. And the latest developments in AI is these two devices which you see out there in the, I mean, see in the slide. So first thing on the left is AWS Deep Lens. This is a hardware device which you could actually buy for less than $250 on Amazon right now. And you can train an AI model right by your desk. You don't have to go into the cloud with Azure ML Engine or Google ML Engine and then pay millions of dollars, not millions, pay quite a bit of money to train AI models. You literally can buy these hardware devices and then train AI models right by your desk under $250. So AWS Deep Lens is a hardware device which is available for AI model training. Then you have Microsoft Vision AI Developer Kit. It's the exact same concept, but it's Microsoft's, and you can train AI models locally inside your house, right? So those are some advancements and things happening in terms of AI and software development, okay? And just final thoughts I wanted to share. There's a common question I get from people, which is, will we lose our jobs? So a recent study by McKinsey, the research firm, found that 400 to 800 million jobs are going to be lost in the upcoming months, right? But they also found that 555 to 890 million jobs are going to be created. And this is not upcoming months, but by 2030, right? So for every job loss, pretty much one or two more jobs are going to be created. So it is safe to say that our jobs as developers and testers are going to be safe, but the way we think about testing and development is going to change, because it's going to be more about AI model training, coming up with different data sets, monitoring the AI model learning and tools associated with that, instead of you trying to have a scripted test case and saying, okay, now let's execute this, let's execute that. But human intervention is really needed, because I don't want to bother you with too many details. But one thing to mention was, when AI model training happens, it'll either say, yeah, this is a round button or a square button, based on the example which I just mentioned, right? But there's also an output called unknown, where the AI model does not know what to do. And the humans have to come and say, okay, dude, this is a square button. Okay, go train. So our jobs are going to be safe, but I think the manufacturing and transportation and retail sectors are going to get affected in terms of more of the blue collar jobs, like Uber drivers are not going to exist anymore. A car will automatically come to you, like the movie Knight Rider, which we thought was fantasy, apparently is real right now. And assembly plants and manufacturing plants, they are going to be affected. But again, just like any other disruptive technology, we just have to retool our skill set and adapt to the changes, right? That's the very essence of being human, right? Continuous learning. So that is something which will help. And don't worry, your jobs are not going to be affected yet, but the way you look at jobs, that's what needs to change. And I have a private Facebook group called Skyrocket Your Career. And say you want to be a data scientist or ML engineer or a software developer or a software tester, and you want to know what are the latest things happening in these kind of jobs, and you want to learn from other people. What I did was, several months ago, I created a private exclusive community where practitioners like us talk about different topics and learn from each other as well. So if you are interested in terms of what an ML engineer does, what a data scientist does, what does a research assistant does, right? Join this private group. And I don't accept everyone in the group, but since you are attending this meetup, I'm assuming you are interested in learning about stuff and advancing your career as well. So get a chance. When you get a chance, you can join the group. And if you see my beautiful face in the group, that means you're in the right group, because there are a lot of Skyrocket Your Career, right? I'm the original one. But the point is, you'll see this. And finally, for those of you who are attending today, I have a special link. If you go to rebrand.ly/skyrocket your career, You can buy the book for $10 today. And once the book launches in end of June, I'll send it right to your house. And you can buy it for $10 if you click on this link. And I'll have it open till end of this week. And yeah, it's up to you. You can always check it out when you get a chance. Finally, if you want to get in touch with me, that's my website, my email address. And every week I send a newsletter out with the latest in technology, various topics on leadership, motivation as well. In fact, last week I just published an article on different AI tools for software development. And so things like that, you'll get notified as soon as I write something or someone shares something. So go and subscribe to my newsletter if you're interested. And that's pretty much it. And I finished 1 minute before our meeting time, but I did start 15 minutes late. But the point is, I don't have any work because I'm jobless pretty much. So I'm going to stick around if you have any question and answers. I mean, questions, but if you don't have anything, it's fine. You always know how to get in touch with me. And again, thanks for having me. I love just talking about AI. I have so much stuff to talk about, but for the purpose of time, I just cutting short to here. Okay. So thanks for listening. I appreciate it. Jess, you're on mute.
All right. Thanks, Raj. I appreciate you taking the time to share about AI with us. We do have a moment here if we have any questions. We had somebody, Amy said she has to run to her next meeting. She enjoyed it. Thanks for doing that. But if anybody else has any questions, you can either open up and share that right now. I tried to... there we go. Get back to the gallery view. So if anybody else has any questions, I was actually going to ask one question to kind of kick it off real quick. Was what kind of tools do you kind of see in the industry for testing that are popular right now, AI based?
That's a great question. Since I'm in contract with a couple of companies, it'll be unfair for me to mention tools. But just to list out different tools. So you have so many different tools out there. You have TestCraft, you have Functionize, you have Mabel, you have TestStim, and then I believe Inflectra started using AI. Their tool vendor as well. And so yeah, those are some tools out there which people are actually using. But this is the thing. Don't blindly just get an AI automation tool, because you need to know what problem you're trying to solve with it. If the problem you're trying to solve is the problem of UI test automation, if bulk of your testing is UI test automation, you want to make life much more simpler for you, then yes, it could be a possible option, right? But in your CI/CD pipeline, if UI tests are only like 5-10% of it, and you have API, unit level, and other tests, which are the majority of the tests, then you probably have to look at other kinds of tools. There are AI-based API testing tools and tools which actually scan your code libraries, the binaries, and then try to find vulnerabilities as well. But yeah, based on different stages and different types of tests you're running, you have different AI tools available. And literally, yeah, everything you could Google or just email me as well. But yeah.
All right, sounds good. Thank you.
Wendy,
nope,
did
I
you
didn't
have a
have
question?
anything. I just put in there in the chat. Thank you very much. It was very helpful. The information was great. It helped me understand several things. I have actually worked with our team on in AI, and so it was helpful. I was like, oh, because I was actually labeling data, and
that's awesome. Yeah.
So
you should talk more. I'm always interested to learn about. For me, I'm from an R&D standpoint. I work with companies, and then I do some labeling and stuff. But you are the person who actually does the labeling, so it'd be awesome to hear your story. Sorry, I didn't mean to cut you up, but you were saying you're labeling things.
Oh yeah, no, yeah, I was labeling, so it helped me when you were going through the different classifications. So I was like, oh, all right, this is what I was doing is I was labeling this data because what we were doing is taking video and then knowing when, like the video starts and when it ends.
Right.
So that we can segment this video up so that people don't have to necessarily do it. It kind of does it on its own.
Nice. Okay.
So yeah, it was interesting. Thanks a lot.
Yeah, thanks for listening.
We're gonna have to wrap this up. I do actually have another meeting I got to run to, so I just want to say thanks again, Raj, for doing this presentation, and we'll make a recording available to our other attendees.
Sounds good. Thanks for having me. Take care.
Thank you.
Thank you.
All right, we'll see you. Bye.
Yeah.